If you've never been in England, every day is different. It's end of April, but you have to wear layers because in the morning it's still cold. But later this afternoon, I'll be taking all of the layers off. But anyway, back to the electrical work. What we have today, we've got this very old fella. It's been here for years. You can tell it's one of those old 100 volts lamp. It's quite powerful, but now we are changing this. We're actually upgrading this to client provided LED light. It's also a motion sensor. As for the driveway and for your bins, for your recycling, it's really useful to have the motion sensor light. We are also changing one of the light at the back. I'm not sure if the back door is open. No, it's secure, so we have to go inside and out to show you. We also have something super interesting inside the house. I'm gonna grab my gear, get in, and I'll show you. Because this one is where the cooker switch is just stuck in the on position and you cannot turn it off. That's gonna be interesting. Is it melted? Is it shorted? Or is it something new? I don't know, but stay tuned. So that's what the switch looks like. A customer has already provided us with the replacement. Very similar one. That's the BG. It's a good English brand. And what we have... This is not going. This is not budging at all. A switch for the socket is working, but that is absolutely not. In this occasion, usually what happens is sometimes there's a massive load on these switches and they just melt. Shouldn't, but they do. But on this occasion we got gas hob and we have electric oven, so that would be excluded. In my opinion, the kind lady was telling me that this had been fitted by the kitchen fitter. So I expect to see a loose connection and actually one of these terminals to be melted. But wait here, I'm gonna turn the power off. Okay, at this point we should take bets of what do you think it is happening behind. Let's flip it. I'm gonna move these out the way. Not seeing anything blatantly obvious, so let's start stripping it. Usually at this point, if the termination would be badly loose, then I would see something right now. I would see box deformed, or could it be that just the equipment failed over time? Well, it could be as well. Okay, what can we see? Nothing out of the obvious, but let's... Right. Well, we've got two screws here. Sometimes we are able to actually dismantle the piece. I'm not sure how about with this model. As you can see, the earth bar joining two sides, it goes over the plate, so I might not be able to take this apart completely. Well, we might be able to bend a few things because, see, that's where the earth is actually joining up with the bar. Let's see if there's a story to be told on the inside.
A few moments later.
Okay. So that's what this looks like on the inside. Yeah, the switch just given up. So that's what it is. It's everything is all apart. Everything is nice. Yeah, everything is loose when you open a switch. And honestly, it just takes a miracle to put it all back together. But I don't see any melting. I don't see anything. So it will be just a failure of the switch over time. Well, we've got a new switch, so that just goes to the bin. Oh, look at this. Got a nice coffee. Tea.
Oh, hell no, man.
Thank you. Right, so what we have, we've got a BG switch, and this one will be just a simple replacement. Looking at the cables in here, so we have 6mm cables supplying the cooker, which is all good. The back box is also being done, earthed, pretty standard. This would be supplied, this would be the load. For any one of you who's wondering, why did the switch stuck in the on position? My initial thought would be one of the two, the overload, but that's not the case, or loose termination. That wasn't the case. So it's actually the switch that gave out. The client told me that this has only been about 2 years since they've renovated the kitchen. Maybe they've used a new switch, maybe they've used the old switch, couldn't tell. But electrical accessory to give up after 2 years, that's not good enough. Tell me in the comments what you think. So we've got load, so this is the load.
Here is a piece of advice for anyone who's actually second fixing the sockets and you've got finishing plate at the back. To avoid scratching it, so this is a plastic socket, so it may not scratch this, but any metal sockets are very likely to scratch the plastic or any abstance behind, so please be careful. Usually I put my hand behind as I'm holding the sockets, so that's just preventing me from that contact and possibility of scratching it. Just a tip for you. We're not longer required to really earth the box because we've got RCD protection, and this is additional protection. If the link to the box is there, let's do it. Now we're going to flip the socket because this is the right way round. Let's do the actual main supply in. We're gonna go get our tester and just do a test from this socket just to make sure that we have good earth loop continuity. We also will test RCD for safety. This is now terminated. Usually what you want to do is wiggle with the cable, give another quarter of a turn, because that's usually what happens. Oh, actually, look, there is a part of the black plastic, and I wonder where is that coming from? Maybe that part was blocking the actual switch. Because it would be good to understand what happened to this switch. So I've got that piece of a plastic. Oh, it's here. There's definitely something chipped out on this side, but that plastic obviously is free. So I imagine that this was broken off at some point. I can't explain how and where, but that piece could be responsible for that switch to be stuck. Well, this is it. That's all going to the bin. Let's put the power back on and go and get our tester. This is my secondary tester. The original one went for repair. Can you imagine? I bought a new tester. This is the flagship of Mega, the best one they offer. Let's put it on, and if we do ZS test onto the socket, turn the socket on, 3-lead low voltage test, 0.94 for a 6mm cable. That's pretty high. I would expect to be much lower. Just as a reference, this is a socket, so let's see what the socket is going to give us. The socket is downstairs, ring circuit, so just as a reference, socket are on 2.5. It should be higher actually. Yeah, 0.69. So that's interesting. Look, this was actually higher than the socket. It's interesting. Sometimes if you clip the sheath from the earth, but yeah. I wonder what would be the reading if we were to take the actual connections from the terminal screws. Let's do that. I'll change that to the crocodile clip so I can just clip it onto the earth terminal. And these two, neutral and live. Okay, what's it gonna be? Is it gonna get lower? 0.95. That's interesting. I've got one more thing I want to check, just in case I've not put the actual terminal too deep. No, it's not. Sometimes if you strip not enough of the cable, the actual terminal screw can go onto the insulation rather than on the copper, and that's what would give you the higher reading. In that case, I'm going to go get my ladder and just pop into the fuse board, because this is the dedicated circuit from the fuse board, and just check on the fuse board side, because this 0.95, I would expect it to be much lower than the sockets. The fuse board looks, it's all been signed off. Customer has done everything they should have done from their perspective. Let's open it up. Okay, so what we found so far is a higher earth loop impedance on the cooker circuit comparing to the actual socket. All looks good so far. So this is the fella that we talk about. So let me just open it up and see if we're not crimping on the... No, we're not. On the actual insulation. We're good there. If we were to trace the neutral's good as well. So is the earth. In that respect, I have nothing else that I would need to check. Everything else looks good. Do you see main incoming cables? Brown and blue. And it goes in here, and it goes there, and there is a tape. And then it actually, right there, it's actually grey. How did they extend the main cables? Crimp? Interesting. Let's test the ZDB. We turn all power off. And we're going to test ZE. When you test ZE, main earth is disconnected. You have to power down everything. Neutral and alive. And we also need to make sure that this is the actual main earth and we're not just picked up on the bonding. 0.26. That's all good. I accept that. So before you energize the installation, you have to make sure you put the earth back in. Well, I don't have an issue with that then, and I don't see anything else. For that point, we're going to... that's the spare one. We're going to re-energize everything back again, and put the cover back on. There's nothing else I can find. And without thorough investigation, the work is completed. The switch is replaced. I've already done what I could in terms of like the quick check and verification of what you should do without taking too much of the time. So we verified the cable is connected here, and it's also the same cable, black and red. The cable is the same here. I've also asked the customer in case if the cooker or the actual supply for the cooker could have been somewhere different and it were aligned here when the kitchen was done 2 years ago, but the customer is pretty sure that this was here always. The only solution that comes to my mind is that if ever this socket was moved as an extended to be here next to the cooker, it was extended with the use of one of the junction boxes, and that's the only solution here, that it would have higher resistance than the 2.5 cable next to it. We will also test the RCD just to make sure that this is actually safe, and if the RCD passes, then I'm happy, confident to sign this off. We're going to go back again, so I still have some faith in that. We're going to go and perform RCD. On this one, I need to check. So if we do times half first, it shouldn't trip. Okay. Yeah, it's on. It's okay. And test. Okay, you see it doesn't do it, so I need to now change to 180 degree AC wavelength. At the bottom is 0, at the top is 180. So test again. And within the new regulations, we are only required to test at times 1, which is the rated value of 30 milliamps, which is here. Okay, so let's do that. 0 degrees, so the bottom of the, and it tripped, 36.5. It's all right, happy with that. At times 1, the RCD has to trip within 300 milliseconds. We were well below that, so which is really good. And now we need to change to the top of the AC wavelength, and it tripped again, 28.6. So RCD is healthy, nothing to worry about that. The higher resistance, it's something that we don't know. But if something happened, RCD will trip, which is a good thing. And the switch is all working fine. Good, okay. Right, so that's that. We have a few more things to do in this property for a customer, so let's crack on and move on.